Hello everyone. Today we are going to look at construction of underground cables. We know very well the underground cables need more protection compared to overhead cables. So we will look at the reason why we need more protection for the underground cables in the later slides. Now we will look at the construction, the structure of the cable. So if you look at here, we have a conductors, we have a paper insulation, lead sheath, bedding, armoring, and serving. So we have different layers. If you just compare this cable with a simple wire in our house, we have just a copper conductor and the insulation. Just simple for the house wiring. We have a simple two things. One is insulation, one is conductor, copper conductor. But if you look at the cables, we have a lot of protections here, protections, layers of insulation. So we will look at one by one what are those and why we have these kind of protection. So core and conductor, core or conductor. So this we already know is that a cable have a conductor. There's a copper or aluminum conductor, usually copper conductor. So if you look at here, we have a copper conductor. This is a conductor, a core. We call this as a core. If you look at here, these are the cores. Cores, we say the core conductors. Then the immediately after the core we have insulation. So insulation is provide a suitable thickness of the insulation depending on the voltage level. So we can, depending on the voltage level, we have a different thickness for the insulation. This is your insulation. Next to the core we have a insulation. So each conductor have a insulation. Surround the conductor we have a insulation for each conductor. Okay, so that's clear. Core and the insulation are basic for any wires. Also it's the same. So we are studying about conductor now. So we have a basic thing, that the core and the insulation. Next we are moving the metallic sheath. So this is a special arrangement for the underground conductors. So metallic sheath to protect the cable from the moisture, gases or other damaging liquids in the soil and atmosphere. So this is a metallic sheath. So if you look at here, this area, this like a tape, or the plastic tape is around it, something like that. So this will a metallic sheath, we call metallic sheath. This is basically protect the cable from the moisture and gases. Next one is a bedding. So bedding, if you look at here, the next to that there's a brown color. This is a bedding. It is also similar to the metallic sheath. We have a like a tape is surrounded by the on the conductor. So to protect the metallic sheath against corrosion, so and from mechanical injury. So corrosion and mechanical injury. So protect the cable from the corrosion and mechanical injury. These two purpose, so this bedding is serving these two purpose. Metallic sheath is serving the moisture and gases. Protect the cable from the moisture and gases, because we are going to lay the conductor underground. So in the underground there can be chemical formation by soil, gas formation. We know, those who are studying about the earth science, they knows that moisture and lot of things are going on under the ground. So that scenario is overhead cables are is a simple. Okay, overhead scenario is totally different from underground scenario. Overhead we have the air and this different kind of setup. Here underground, there may be moisture created, gases created. So those gases can damage this metallic sheath. That's why we have this the cables. That's why we have a metallic sheath to protect the cable. Here from corrosion and the mechanical injury. To protect the cable from corrosion and mechanical injury, we are using bedding. So next we have armoring. So armoring, if you look at here, this is armoring. If you look at this is like a, it's like a little bit of twisted things. Is like a protecting. You might see these kind of things in the packaging as well. Some important packaging, some machinery packaging or some important component packaging. They do this kind of armoring. So armoring it to protect from the mechanical injury. You can see that to protect from the mechanical injury while laying. So if you can imagine, compare this with the some as I said, like some equipments come with this kind of armoring kind of setup. Like if you press, this will not damage the cable. If you press, it's like it's moving. These armoring these setups are moving. So consists of one or two layers of galvanized steel wire. So this is a galvanized steel wire or steel tape to protect the cable from the mechanical injury while laying. So it's like a flexible galvanized steel wire, so that will move here and there when you laying the cable. It won't impact or it won't damage the cable. Okay, this you can understand clearly. Then we move to serving. The last one is serving. That's a topmost outer cover. So this is to protect the armoring from atmospheric condition. All armoring, we have armoring, we have to protect the armor. We cannot leave this armoring as a last layer. So because it's like a you know that it's like a movable little bit of steel wires. So we have to protect that, and we are putting the serving. So now you can summarize with all these layers of protection because we are laying the conductor in the underground. So let's look at what are the reasons. So this will clarify why we have a different kind of setup in comparison to the overhead, require more protection compared to overhead conductor. So overhead cables or conductors. Okay. So, mechanical stress and physical damage. The underground cables have more mechanical stress because we are laying underground, so it's not easy as laying in the overhead. So we have to pull through the underground. Maybe they dig a hole one place, another hole another place. They somehow pull the cable, or they put some a lot of the mechanical works going on. You can imagine how difficult laying underground. So those they put the pipes, the plastic pipes or something underground, then pull the cables, a lot of things. So it's a lot of mechanical stress compared to the overhead cable. So we need to protection from the mechanical stress and physical damage. Physical damage in terms of when the underground cables goes nearby road or the side of the road, there are vehicles can park by the road. I mean, the vehicle, the traveling vehicle can become a stress on the ground. So heavy load applied to the ground. So these cable should capable of protecting from these heavy loads. Heavy loads pushing the soil, so soil pushing the cable. So this is another reason. Then environmental exposure. The soil moisture can cause corrosion. So soils, as I said, explained earlier, soil moisture can create corrosion on the cables or conductors. So that's why we need more protection. And chemicals in the soil. So soil can have the chemical as well, or chemical can be generated or created in the soil, that we need to protect the cable from those chemicals. Then we need to have a thermal management. So what is thermal management mean? In overhead conductors, there is a good heat dissipation by air. Air is a good medium to transfer heat from one place to another place. So unfortunately, in the underground cables, we don't have air to transfer the heat, dissipate the heat, remove the heat from the cable. So unfortunately, underground cable may experience a high temperature situation when conducting more current. It may has to withstand the high temperature. So that's why we need thermal management as well. So to manage thermal, so it may simply the cable should be capable of handling high temperature. So that's why it's called thermal management. The cable, we had to design the cable uh, in order to handle high temperature. The last one is a fault detection and repair challenges. We know that in the overhead conductors, repairing is quite easy. We put the ladder and step up into the poles and look at. Even though it's a dangerous job, but we can easily visibly see what is the problem. We can do it. But look at underground cable. Like every time fault happens, we have to dig the hole and remove the cable. Or it's a lot of work. Is compared to overhead reparation, the underground repairing is a huge work involved. So we want to minimize the chances of risk of damaging cable, so that we can reduce the risk of repair, or reduce the chances of repair, so that we can reduce the repair time or increase the protection time. So that is a last reason why we need the fault protection for the cables. I think that's all for today. Thank you very much. Please subscribe this channel and continue providing your support to this channel.